Hello and welcome to part 1 of Water, Frequencies and Health. These series are complementary to my series The Secret of Water, where I just published a second episode last Thursday. And so you might find some additional information in the other series. So keep posted on both of these series. Water and its unique properties. We talk here about the water cycle first. If you look at this graph here, you see first of all, in the ocean you have most of the evaporation happening, and of these 425 times 1,000 cubic kilometers per year, most of it will precipitate again in the ocean, but a part will be then going as clouds into the land side and will precipitate the big part of it in the mountains, and there the bigger part will be going into the underground. One part will remain at the top of the mountains as snow and later ice, and this will be delivering water in warm periods. When there's no precipitation, then these snowpacks and ice packs, they will be melting and delivering water into the creeks, rivers and lakes at these critical periods. And the second thing you see here, which is really interesting, is that the bigger part of the water is not flowing at the surface as rivers, creeks, or also as lakes, and then landing into the ocean on a surface with a river. No, the biggest part of the water is infiltrated into the ground and will go as groundwater flow towards the ocean finally as well. This groundwater flow is really slow compared to the flow at the surface, and by going through all these sandy or rock parts in this very slow manner, it is being filtered and cleaned. So usually if you have a well and you pump groundwater, this water will be of really good quality. Of course, we have more and more infiltration of maybe chemicals and other parts which are not as good for the water, at least if we want to drink it or if we want to give it to animals and plants. So there we might have to take additional measures in cleaning this water. One important part in this cycle of the water, which is the influence on the water. Today we have a very high intensity of technical radiation. So this technical radiation will already take place in influencing the water in the clouds and also during its precipitation as rain. Water in form of rain, of course, is also very receptive, as I also explained in earlier editions, to any radiation in the environment. So this might then influence also the capacity of the water to infiltrate into the soil. Now, if we look at the next slide, and here we look at the ideal complete water cycle, where really, as I said before, the biggest part of the water is infiltrating into the ground, forming a very important groundwater table and delivering water to the forests, where the forests will make evapotranspiration. And this is key for keeping our climate in livable conditions, in livable temperatures. Today, we have a partly broken water cycle. Victor Schauberger called it a reduced water cycle, where we have very little water infiltrating into the underground. Yeah, sadly, this is today's standard situation, where we have the bigger part of the precipitation flowing away on the surface, and this is damaging the soil, the part where the humus is, which took thousands of years to build up and deliver a good underground for the plants to grow. The plants, which of course are at the beginning of the food cycle. I will be going into why this is exactly happening from a point of view of frequencies and harmonic ratios in a later edition. Let's look at the water occurrence. If you look at these three pillars here, the first one to the left, you'll see that 96.5% of the water is in the oceans. Then we have other saline water, which is just roughly 1%, and fresh water is only 2.5% of this total amount of water on Earth. If we look now at this 2.5% represented in the second pillar, we see that roughly 2/3 is in the glaciers and the ice caps in a frozen state. And 30% is in the groundwater. And on the surface, we only have 1.2%. This explains also why we have to make wells and get to fresh water in the groundwater, because surface water in many areas of the earth, at least at certain periods, there's not enough of it available. Now let's look at this 1.2% of surface and other fresh water in the third pillar. There we see that a little part is in the atmosphere, a very tiny part, 0.26% in living things, 0.5% in rivers, and 2.6% in swamps and marshes, 3.8% in soil moisture, 21% in lakes, and in ground ice and permafrost is the whole rest of 69%. The aggregate states of water, there are for every element 3 states: the solid state, the liquid state, and the gaseous state. The water has a solid state as ice or snow. Then the liquid state, the water, this nourishes us all, allows us to live. And then we've got the third state, which is vapor, which is in fact not the clouds, because the clouds are already tiny little water drops. The vapor is not visible. It makes part of our air which we breathe. If we look at the energy required to heat up water from 0 to 100 degrees Celsius, meaning from just when it has melted from the ice state, bringing it up to 100 degrees, where it then, a moment given, would be turning into vapor. We have 2 barriers there. One barrier is at 0 degrees. I'm talking about energy barriers, because to bring this 0 degrees cold water into ice, it requires again as much energy as it has taken to bring it down from 100 degrees to 0 degrees. So this means we've got a really strong energy barrier before it would turn into ice, which allows us to have water available for a very, very long time before it would be freezing. The same is on the upper barrier at 100 degrees Celsius, where it would turn into vapor. And there again, we've got a same strong energy barrier. So much energy is required to evaporate this water. This is again really important to keep the water in liquid state for a very, very long time. We now are looking at water in living beings. In human beings, this is around 70% of our weight, which is water. In animals, it is similar, but it can go, depending on what animal it is, up to 90%. And same in plants. Plants can have up to 90% of their weight being water. New findings that have been developed on that water in the cells of living organisms. And this is today called the fourth phase of water. Professor Gerald Pollack was responsible for developing this topic. This topic will require a special edition of our information on water. Another water anomaly is important to allow life on our earth. And this is the density of the water in certain moments. The first one is that water usually becomes slightly less dense the higher the temperature is, but when you get close to 0 degrees Celsius, we see that the specific weight of water is the highest at 4 degrees Celsius, and it becomes less dense below 4 degrees Celsius towards 0 degrees. The second is that the density of the solid state of water, of ice, is lighter than the liquid state, which is totally unusual because basically any other element is heavier in its solid state than in its liquid state, but water not. And now, if you look at this image here, this really allows preserving life in winter time, in cold periods, in areas where it's often very, very cold, below 0 degrees Celsius, below the freezing point. You see here a lake to give you the understanding of why this is so important. The ice, because it's lighter, it is on top. It will freeze on top of a lake, and it will make a protection cover against the cold coming from above. And then we've got, of course, warm energy coming from the inside of our planet. It can be minus 20, minus 30 degrees Celsius there, and this will allow a strong protection of this water. The same thing you can see in mountain creeks. I grew up in the mountains, and I kind of just got used to this fact that we've got this ice cover above on these creeks, and below we still had the flow of these creeks down the valley. This is key for life on Earth. So if I make a summary, the solid state of water is lighter than the liquid state of water. The maximum density there is a plus 4 degrees Celsius, and the gaseous state, the water of course, is as light as air. I would like to refer to the second edition of The Secret of Water Insights, where I was explaining in detail the water molecule and its properties as a dipole, its very tiny size, its sensitivity to anything electromagnetically happening in the ambience, and also these hydrogen bonds. All this is explained in The Secret of Water Insights episode 2. In this episode 2, I also explained how water will dissolve salts and minerals. So once these minerals are dissolved, we might have a water with little quantity of dissolved salts, minerals, few ions, and this water with few minerals has a low conductivity, meaning if I would put electricity into this water, it will be slowed down. Now we look at the water with many ions dissolved, like for typically seawater, then there's a very high conductivity. Electricity can flow through this water very easily. This was part 1 of water frequencies and health. In a week we will be talking about evaporated water drops in our series The Secret of Water Insights. If you like this, please subscribe to my channel, and I wish you a great day. Take care.